In this lesson, we shall focus on mathematics paper 2 for grade 11. Right, we shall focus on some parts of this exam that was written in November 2018 by the grade 11s. It was written in 3 hours out of 150 marks. Now, we will go through some of the questions in this past exam paper, and we are getting started right now as follows. Okay. Our focus is gonna be on some of the sections. Because it's June now this year, 2024, June. So not all the topics have been covered in the schools, and therefore we focus on the topics that the June students need to be acquainted with, etc. Now, question 3 is what we're gonna start by doing in the diagram. You have A with the coordinates -2 and 2, B with the coordinates 6 and 5, C with the coordinates 0 and -3, and D with the coordinates x and y are the vertices of a quadrilateral having AD parallel to BC. So you have that AD is parallel to BC. So here is A, here is D, here is B, and here is C. And obviously the parallel lines have been marked as parallel. BA produces an x-intercept at E. Okay, so there's BA that has been extended, and obviously it has been produced. It has an x-intercept at E. Now, BD and AC intersect at M. Okay, so you have BD and AC intersect at M. N with the coordinates T and 0 is a point on AD. So you have N with the coordinates T and 0 is a point on AD. Calculate the gradient of BC. So we'd be interested in finding the gradient of BC. Okay, now we start as follows. Right, to find the gradient of BC, now we have this point B, and we can mark B as x1, y1. We can label the coordinates x2, y2, and therefore we need a gradient of BC. Right, so it is actually y2 minus y1 divided by x2 minus x1. Okay, this is the gradient. But the gradient of BC equals, what is y2? Y2 is -3, y1 is a 5. Divided by x2. x2 here is 0 minus x1, which is 6. The gradient of BC. -3 minus 5 is -8. Okay, -3 minus 5 is -8 divided by -6, and therefore we divide, the negative divides negative, giving us a positive, and we divide through by 2, giving us actually a 4 out of 3. Obviously, we can see this line here. It's a line that is running up slope. It is obviously a line with a positive gradient, and therefore one can say thus the gradient which we want to, of the line BC is 4 out of 3. So the gradient of BC is 4/3. Okay, so any question on that? Right, so that is what we have here. Okay, and that is what the examiner asked us to find the gradient of BC, and we found that the gradient of BC is 4/3. We move to the next question. Once again, I may need to take note of the fact that this discussion is being recorded for control and quality purposes, and therefore you'll have continuous access to the recording at any given time. Right, so you'll have access to the recording at any given time. We have found the gradient of BC. How to define the gradient of BC? We use the gradient formula. And this kind of gradient is called average. Is referred to as what we call average gradient. Is referred to as average gradient. Let's look at the next question. Now you need to determine the equation of AD. AD. You're interested in finding the equation of AD. Right, so to find the equation of AD, first and foremost, we must note that the gradient of AD equals the gradient of BC because these are parallel lines. So we note that first to find the equation of AD, we need the gradient of AD. So we will write therefore that the gradient of AD is equal to the gradient of BC which is 4/3. Why? Because AD is parallel to BC. Okay, parallel lines have equal gradients. Okay, so we use that fact. And therefore, we proceed to realize that the formula we shall use is y minus y1 equals m into x minus x1. This is called the slope point form. Now, at this point, we realize that this particular equation of the line passes through. Right, so it passes through the point. Right, it passes through the point. Now, if you look at the AD, it passes through the point A with the coordinates -2 and 2. And therefore, this point would give us x1, y1. Upon substitution to the equation, we have y minus y1, which is 2. The gradient is 4/3. X minus x1, which is -2, like so. Okay, y minus 2 equals, we have 4/3 x plus 2. Okay, multiply negative by negative, that gives us a plus. And this therefore gives us, if you multiply through here, you have 4/3 x, okay, 4 by 2 gives us exactly 8/3. Okay, the -2 brought across becomes a +2. And this, therefore, is carried forward to this side of the screen. And this means that y equals 4/3 x, right? And we add 8/3 plus 2. So it's multiplied 3 by 2, giving us a 6. 6 plus 8 gives us exactly 14. Right, so we have exactly 14/3. 14/3. And therefore, this is the answer. So to find the equation of AD, we have y equals 4/3x plus 14/3. Okay, so that is the answer. Right, any question? Do you have any question? No question. Okay, right, we found the equation of AD. Now, here is A and here is D. To find the equation of AD, we first had to find the gradient of the line AD. To find the gradient of AD, because the point D wasn't given explicitly, and therefore we used the fact that the line AD is parallel to BC. Parallel lines have equal gradients, but also the line AD passes through the point A with the coordinates -2 and 2, and we have that sealed there. Next point. Okay. Right, we're interested in determining the value of t. Here is t, and we want to find the numerical value of t. Right, but what do we know about t? The point N with the coordinates t and 0 is a point on AD. So N is actually a point on the line AD, but now this N is the x-intercept of AD. So it is an x-intercept. How do you find an x-intercept? You already know, therefore, we want to find an x-intercept. Right, so to find an x-intercept, we need to let y be 0 in view of the former equation. The former equation, y equals 4/3x. y equals 4/3x. Okay, so this means that y equals 4/3x plus 14/3. Right, plus 14/3. All right, so we are interested, therefore, in finding the the x-intercept of the line AD. So to find the x-intercept, we let y be equal to 0. Okay, so if y equals 0, because we want to find the value of t, t is the x-coordinate of the point N, and therefore we let y be 0 in the equation of this line, because the line AD has the equation. What equation does it have? It has the equation y equals 4/3x plus 14/3. Okay, if y is 0 here, you have 0 equals 4 over 3x plus 14 over 3. We multiply through by 3. Okay, right. If you multiply through by 3, it means therefore you would take 3 times 0 equals 3 times 4 out of 3x plus 3 times 14 thirds. 0 equals 4x plus 14. Okay, meaning you have 4x equals minus 14. And therefore, x becomes equals to minus 14 out of 4. And this means that x equals, if you have minus 14 out of 4, it's equal to minus 7 out of 2. And obviously, I mean, it means a couple of things. You would realize, therefore, that one thing you could do is to realize that therefore, t is actually equal to minus 7 over 2. Right, because to find out, you realize that t is an x, is the x component. T is the x component of the point n. Right, and therefore t being the x component of the point n, we have found already the numerical value of t there. Okay, the couple of ways of us to do that. Alternatively, a student can do the following. Right, so as an alternative, alternatively, a student can say, you have the line y equals this one here, which is the equation of the line AD, 4/3 x. Right, so you have 4/3 x plus 14/3. Okay, but now this line passes through. Right, it passes through n. The line AD passes through n with the coordinates t and 0. Okay, obviously t and 0 give us x and y. Okay, and therefore our y here is 0, 4/3 x, which is t plus 14/3. And then we solve for t. Okay, we've already solved for t, and we get that t is minus 7 out of 2. Okay, so that would be another way to do the question using the fact that this line AD passes through the point n with the coordinates t and 0. Okay, with the coordinates t and 0. Okay, we have found the value of t, and the value of t in this question is minus 7 out of 2. This discussion is being recorded for control and quality purposes. You'll always have access to the recording at any time there of the year until the end of the year. Okay, so you can access this recording and to be able to watch and understand what is happening in case the network can fail from time to time. But yeah, the recording is always going to be perfect. The recording is going to be posted on the WhatsApp group as well. Next question. Okay, the information above still remains the same, but in 3.4, we want to calculate the length of AN. AN. We want to find the length of AN. Okay, but already we know the coordinates of T. The coordinates of T, or the numerical value of T. The numerical value of T is minus 7 out of 2. So we put it here. This is minus 7 out of 2 and 0. So at this point, it's x1, y1, and this is x2, y2. We want to find the length. And to find length, the minute the examiner says length, it means you need to use the distance formula. So which means that you're going to say AN equals x2 minus x1 squared plus y2 minus y1 squared, and you have here the square root, which means that AN equals the square root. Okay, you are dealing with AN, so now to find the length, use the length formula, the distance formula. Okay, what is x2? X2 is minus 7 out of 2, so you have minus 7 out of 2 minus x1. X1 is a minus 2. You square this plus y2 is 0 minus y1, it's 2 squared, which means that we have AN equals the square root. Right, we have here minus 7 minus 7 out of 2 plus 2. Okay, because negative by negative, it's plus. You square this. Now, minus 2 squared gives us a 4. Okay, and this becomes the square root of the following. Okay, if you have minus 7 out of 2 plus 2 is like 2 times 2 here, which is a 4. 4 minus 7 gives us minus 3 out of 2, and you square this, and it's 4 that is added to the whole thing. Okay, and now upon careful examination, what is all this here? So these can be seen as exactly, if you square 3, it becomes a 9 out of 4 plus 4. 4 by 4 is 16. 16 by 9 is 25 out of 4, which is 5 out of 2 units. Okay, 5 out of 2 units. So, and obviously you can therefore say here, thus, AN itself is 5 divided by 2 units, and that is the length that is required. So you see, I mean, if you have a question, you let us know. But this is what happens. All right, it is the length of AN that is 5 out of 2 units, and we have solved the problem, and we're done. We continue to do more problems. Continue to answer the next question. But obviously, I mean, in the event that you have a question, you let us know that you have a question, and we can attempt to answer your question and offer you the assistance you most certainly need there. Okay, right. We proceed to the next question. This was 3.4 that we've just solved. We move on to the next question, and the next question is 3.5. Right, if DC is defined by the following equation. So we have DC, here it's D, the point D, here is the point C. They're points on the Cartesian plane, and they are defined by the line whose equation is given here. Determine the coordinates of D. Right, so there is here the line segment DC, whose equation is 3 out of 8x minus 3. And you want to calculate the coordinates of D. And to calculate the coordinates of D, there are a couple of things that remain very, very pivotal here. The question becomes, how do we find the coordinates of D? And I know that to find the coordinates of D is something very, very straightforward, because you have already been given the equation of the line there. And also, you already know the equation of the line AD, right? And we found the equation of the line AD as well. So there are a couple of ways to do this one. What is the equation of the line AD? The equation of the line AD, in 3.2, we're asked to find the equation of the line AD. The equation of the line AD is 4/3 x plus 14/3. Y equals 4/3 x plus 14/3. We take that one and we use it there. So now it is 4/3 x plus 14/3. And this gives us the equation of the line AD. All right. And now we continue to then say in 3.5, we want to now determine the coordinates of D. And to find the coordinates of D, we find the point of intersection. So D is the point of intersection of the two lines. So we're dealing with a point, right? We're dealing with the point of intersection. Okay, now dealing with the point of intersection, what do we do with the point of intersection? Point of intersection means y equals y. Okay, so if y equals y, we continue to then say, what is our other equation? So you'd have, therefore, that we have 3 out of 8x minus 3, which equals our y, which is 4 out of 3x plus 14 out of 3. Okay, we then continue to then say, at this point, we want to determine the coordinates of D. And to find the coordinates of D, there are a couple of things that remain very important. How do we find the coordinates of D? We will need to solve for x from this equation, because this is how we find the point of intersection. So to find to determine the value of x out of this, we need to take into account that what we have here is the following. We multiply it through by 24. So we can take 24 times 3 out of 8x minus 24 times 3, and this is 24 times, so this is an x, okay? This one here is an x, right? So this here remains an x, right? And we have the 24 out of 3x plus 14 out of 3. Okay, like this, right? So 8 goes how many times in 24? 3 times, and 3 by 3, it's 9. That gives us exactly 9x. Okay, now 24 by 3, 24 by 2 is 48. So the 52, and then you have exactly 72. So this one is going to give us 72. All right, now 3 goes how many times in 24? It goes 8 times, and 8 by 4 gives us what? Gives us exactly 32x plus, right, obviously, you might also multiply this one here by 24. So in other words, we took 24, we multiplied each of the terms. Why? Because 8 times 3 is 24, and that gives us what you call the LCD, the lowest common denominator, which arises from what you call the lowest common multiple. And the lowest common multiple at this point is a 24, and the 24 is a product of the 8 and the 3, which are the denominators. Okay, now 3 goes into 24, giving us 8, and therefore, what is 8 by 24? Right, so we can be, in particular, 8 by 14. Right, so we're going to have 8 by 14. Right, so because we divide 24 by 3, getting an 8. So we have 8 by 14. What is 8 by 14? Right, so we have 14 by 8. 14 by 8, which is 112. And therefore, at this point, this is the same as what? This is exactly the same as 32x minus 9x. Right, giving us exactly 72 minus 112. So it's 72 minus 112. And what is 72 minus 112? Right, so you take the 72 minus 112. So if you then say 72 minus 112, what we're getting is exactly minus 40. So here you're going to have minus 40, which is exactly equal to, now you then have 32x, you have 32 minus 9, and 32 minus 9, it gives us exactly 23x, okay? Right, so now let us look at this and make sure that we have obviously made no mistake over here, and we want to get the answer that is actually required. Right, so we want to get exactly the x. So what is x here precisely? Let's just check and make sure that we have the correct answer. Okay, right, we have had this, we divided, we multiplied through by 24, and just need to verify to make sure that everything is okay here. And these gave us exactly a 9x, and this gives us a 72. Okay, make sure that we're getting the right answers here. So if you have 24 by 3, all right, 24 by 3 is 72. Okay, and this is actually 24 divided by 3 gives us 8, and 8 by 4. 8 by 4 gives us exactly 32. And we have this part here. So here, 24 divided by 3 gives us an 8. And therefore, we have 8 by 14. And 8 by 14 gives us exactly 112. Okay, we good. We good. I'm just cross-checking that our algebra is correct here. And therefore, if algebra is correct, then we went on to then say, if you have 72 minus 112, this gives us exactly a minus 40, and this gives us exactly a 23. And therefore, let us check what we're getting here. If this is very, very correct, and we actually need to get the correct result. And yeah, okay. Cross check, cross check, cross check, cross check. Let me cross check here. I think that something is not adding up. Something is not adding up again and again. Okay, let's see. You've multiplied by 24 here, and this is 3. And right, so you have the 3, you multiply by 24, you multiply by 24, multiply by 24. Let me see, I'm trying to check if anything is adding up. This is a 3. And the 24 here, okay, yeah, the sign issue here. Okay, because here it's minus, so this must remain minus. Okay, just make sure. So now when you get to this pointer, you have 112 coming across, and it's therefore going to be minus 112, but it's finding minus 72. Okay, so there's minus 72 here, minus 112. So yeah, that's fine. That's okay now. So in the end, then what we're then getting is we have 72 and 112, and if you add them up, they give exactly 184. Cross-check that one. Okay, right. So they give exactly here 184. Right, so they give exactly minus 184. Okay, so if they give exactly minus 184, just simplify these together. So you carry these to this side of the board. Upon division both left and right, you have minus 184, you divide it by 23. Okay, and this gives us 184 divided by 23. So if you have 184, you divide by 23, this gives us exactly minus 8. Very correct answer. Okay, so if we have minus 8 here as the value of x, we want to remember find the coordinate of d. So there are many ways that we have to find the coordinate of d, but yeah, we're good. Now, we found x and we need to get a y. And to get y, we can use any of the equations. We shall use this one, which has relatively smaller numbers and fewer fractions. We shall use uh, this equation here. So because the equation of DC is given by y equals 3 out of 8x minus 3, which is the equation of DC, right? Meaning that we shall use y, which equals 3 out of 8x minus 3. So you're going to use y equals 3 out of 8. But what is our x? Our x is minus 8 minus 3. Okay, and upon careful multiplication here, this 8 cancels out, giving us a negative 1. Multiplied by 3 gives us minus 3, and this gives us a minus 6. Pay attention to this. And as a consequence, we have d, and we have the coordinates of x, which are minus 8, minus 6. Okay, right. So look at that one. So the coordinates of D are therefore minus 8 and minus 6. Okay, I know that somebody will be like, okay, if I'm asked here to find the coordinates of D, we can use lots of things. We can use lots and lots of properties of quads. But remember that here the examiner told us that these here are vertices of quadrilateral having AD parallel to BC, and BA produces an x-intercept at E. Okay, so you have all these here, and what is very important then is therefore that these coordinates are coordinates of the point D, and D is a point in the third quadrant in which both x and y are supposed to be negative. So you have a chance to ask questions. In the absence of questions, we proceed to the next question and we solve as many questions as possible. This will be one section we're going to do, but also we shall do many more sections moving forward. Next question. Our discussion tomorrow is going to be science based for those who are writing science. I have some students who are going to be writing science tomorrow, in which case, therefore, you have a perfect chance to engage with us and make sure you learn more physics, you learn more chemistry for those who are going to be writing their chemistry paper on Monday, and for those who are going to be writing their physics paper as well. I mean, we have different students. Okay, prove that ABCD is a parallelogram. So the examiner's saying prove that ABCD is a parallelogram. So to prove that ABCD is a parallelogram, you need to take into account a couple of things that remain very, very important. So, right, so to prove that ABCD is a parallelogram, what do we do? We take into account basic stuff. And how do you prove a parallelogram? So you need to prove that the opposite sides are parallel, and also you can always show that the opposite sides are of the same length and the diagonals bisect each other. So now in 3.6, we'd have to verify therefore that the gradient of AB Right, the gradient of AB is y2 minus y1 divided by x2 minus x1. Okay, we're dealing with AB, so we have x1, y1, and we have x2, y2. What is y2 here? It is actually 5. Y1 is 2 divided by x2 is a 6. X1 is minus 2. And therefore, we have 5 minus 2 giving us a 3, and you have 6 plus 2, and this gives us 8. Okay, so this gives us exactly the gradient of the line AB. We already know that AD is parallel to BC. And now we continue to write the following. We continue to do the following here. Okay, all right, so we're good. Now, the couple of things, therefore, that are very important, but we already know that. But now AB, right, the gradient of AB, because we know the gradient of AB is 3 out of 8, is equal to the gradient of DC. Right, so what is the gradient of DC? Because they've already given us the equation of this line. What did the examiner say? They said the equation, if DC is defined by the equation, right, is defined by the equation y equals 3 out of 8x minus 3. 3 out of 8x minus 3. So 3 out of 8 x minus 3. So this is the defining equation. Sorry. Yeah, so the gradient of DC. Okay, I want to mention here, let's just make mention of the fact that here, the gradient of DC. Right, so the gradient of DC is equal to what? Right, so the gradient of DC at this point is 3 out of 8. Okay, the gradient of AB is 3 out of 8. Yeah, gradient of AB is 3 out of 8. The gradient of DC is 3 out of 8. So, and that's the gradient. And thus, what we're having is that the gradient of AB is equal to the gradient of DC. And because they are both equal to 3 out of 8. Okay, now I want to mention a couple of things. The gradient of AB is 3 out of 8. Why is the gradient of AB 3 out of 8? We calculated that one. The gradient of AB, we calculated it because we know the coordinates of A and the coordinates of B, and therefore we found the gradient. Now, with DC, now the gradient was known because the examiner gave us the equation of the line DC. Pay attention. The couple of things that therefore are at the heart of the operations. Now, we need to take into account a lot of things. And the fact that because we know that the gradient of the line AB is 3 out of 8, but also the gradient of the line DC is actually 3 out of 8. Okay, so 3 out of 8, 3 out of 8, and these gradients are equal to each other. And therefore, we say the following. So, yeah, we say therefore, AB is parallel to BC. Okay, AB is parallel to DC. Why? Because parallel lines have equal gradients. The minute in what you call analytical geometry, okay, this section we're doing is called analytical geometry. Okay, this discussion is, this lesson is being recorded. Okay, if you don't want to call it analytical geometry, we call it coordinate. We call it coordinate geometry. Okay, we call it coordinate geometry. So in the end, then what we have is that the gradient of the line AB here, the gradient of the line AB obviously is equal to the gradient of the line DC because they're both 3 out of 8, and therefore AB is parallel to DC. Okay, AB parallel to DC, examiner. Okay, parallel to DC. Take note of that. So it's parallel to DC. Okay, right. Now, but what do we know? So we can put a but AD is parallel to BC. Okay, but we already know that AD is parallel to DC. Obviously, I mean, why are these parallel? Well, they're parallel. AD parallel to BC. We can even say they're parallel because it was given by the examiner. This was a given fact. Okay. Now, because you have that the opposite sides are parallel, all four. Now, the pair of opposite sides here parallel, pair of the opposite sides are parallel. Therefore, we have that A, B, C, D. Therefore, we have that A, B, C, D is a parallelogram. A, B, C, D is a parallelogram. So we have A, B, C, D is a parallelogram. So obviously, I mean, we need to bring reasons for this. Why is this the case? Because opposite, because the opposite sides are parallel. So you have that opposite sides are parallel. Because the opposite sides are parallel, it follows therefore that we have a parallelogram up here. Okay, right. There are many ways to do this, but you can also prove that the diagonals here bisect each other. So you can also find the midpoint of AC and also find the midpoint of BD and show that BD and AC have the same midpoint. Okay, because you find the midpoint of BD and realize that is the same as the midpoint of AC, and therefore you are done. Next question. We need to calculate the coordinates of M. We need to calculate the coordinates of M. Right, to find the coordinates of M, there are a couple of things that remain very, very important. How do you find the coordinates of M, sir? Now, M is the midpoint of AC. Right, so now, M is the midpoint of AC. And therefore, because this is a parallelogram already, and therefore we know that M is the midpoint of the diagonals. Okay, right. So how do we therefore find the midpoint of AC? Right, A is an initial point, and C can be regarded as an end point. And therefore, we want to find the coordinates of the midpoint. We write capital M, and we put here x1 plus x2. You divide by 2, but you also put y1 plus y2, we divide by 2, like so. Okay, this is equal to m, and therefore we put x1, which is minus 2 plus x2 is a 0. You divide by 2, y1 it's 2, and minus 3, you divide by 2. Okay, like so. Okay, yeah. So what is minus 2 divided by 2? It's a minus 1, and 2 minus 3 is minus 1 out of 2, like so. Right, and this has given us the coordinates of M, because now the examiner said calculate the coordinates of M, and the coordinates of M, and therefore minus 1 and minus 1/2. Okay, and therefore if it's minus 1 and minus 1/2, we have therefore found the coordinates of the point M. So pay attention to these and make sure that obviously all is well. And we proceed to the next question. Okay, now these are the coordinates of M. So what is M? M is the midpoint. So M is the midpoint. Okay, it is the midpoint. It is the midpoint of AC. So M is the midpoint of AC. How do we find the midpoint? This formula is called the midpoint. It is called the midpoint formula. This is called the midpoint formula. So pay attention and make sure that all is well and you learn everything in order. Okay, so yeah, so we continue to analyze the mathematics here and move to the next question. Right, question 4, it's more on still analytical geometry, but we learn a little bit more things here. In question 4 has a question. The question as follows. Now, in the diagram, F is the coordinates 2 and minus 2, right? G is the coordinates of 5 and 2, and C is the coordinates 6 and Y, are the vertices of triangle FGC. So these are the vertices of triangle FGC. Now, FG is perpendicular to FC. So you have that FG is perpendicular to FC. Now, N is a point on FG. So N is a point on FG. Here is N as a point on the line segment FG, such that the inclination of NC is 104,04 degrees. Okay, so you have the 104,04 degrees is the angle of inclination of the line N to C. Okay, good. We excited. Now, this is so interesting to us. And we proceed to the next question. In proceeding to the next question, we solve. But we solve these questions in detail as follows. Now, we want to first things first, calculate the gradient of FG. Right, here is F and here is G, and we want to find the gradient. Remember, once the examiner says FG, it means that we are moving from F to G. So F is x1, y1, and G is x2, y2, which means that you need the gradient of FG. Okay, the gradient of FG is y2 minus y1 and divided by x2 minus x1. Once again, for those who are writing science, our lesson tomorrow is going to be on science. Right, so y2, therefore, it's 2 minus y1 is minus 2 divided by x2, which is actually 5 divided by x1, which is a 2. Negative by negative, it's plus 2 plus 2 is a 4 divided by 3. So this is the gradient of the line FG. It is 4/3. Okay. So now this means that we can certainly be able to say here that the gradient of FG is 4/3. The gradient of FG is actually 4/3. All right. So we good. Right, so we continue to solve more problems. The next thing is we're going to focus on 4.2. We want to calculate the value of y. And to calculate the value of y, we do the following. Right, so here is y, and we want to find the value of y. Y is nothing other than the y coordinate of the point C. Right, so dealing with the y coordinate of the point C, we proceed to find the coordinates of y in the next question. Right, so this one we've already done, and we proceed to want to find the value of y. So if y is this one here, there are really a couple of ways to find the value of y, but most importantly, we need to take note of the fact that the value of y can be obtained as follows. Right, so we need to take note of the fact that we have a couple of equations. Like what do we know? We already know the gradient of the line FG. Okay, but now we would like, I mean, if we knew something else, for example, if you knew the equation of the line GC, you could easily do that. And that is what we need to know. Right, so, and that is the information we need. Right, because at this point, what would the gradient of the line, for instance, FC be? What would the gradient of the line FC? Because we know that FC itself and FG are perpendicular to each other. Okay, so now, if you have perpendicular lines, then the product of their gradients equals -1. So we can use most certainly that fact over there. So we can then say that the gradient. So the gradient of FG, right? We've already got that one in the previous question. The gradient of FG is 4/3. So we carry it forward. So we'd come here and then say the gradient of 4G is 4/3, right? This has been proved or obtained in 4.1. Okay, right. So we know that the gradient of FG is 4/3. Then you'd have the gradient of FC. The gradient of FC times the gradient of FG is -1. YFC is perpendicular to FG. So that now we have the gradient of FC, right? So the gradient of FC times the gradient of FG, which is 4/3, equals -1. So which means the gradient of FC equals, you flip this, it becomes -3/4. Okay, this gives us exactly the gradient of FC. So we got that the gradient of FC is equal to -3/4. -3/4. Okay, if the gradient of FC is -3/4, we continue the 4. We want to find the equation. We want to find the y there. So we can use y, right? We can use y minus y1 equals m into x minus x1. This is called the slope point form of the equation of a line. This equation of the line passes through, okay, it passes through f with coordinates 2, -2. Right, giving us x1, y1, okay, which is y minus -2 equals m equals -3/4 into x minus x1, 2. Okay, minus here, giving us y plus 2 equals, okay, multiply through here, which is -3/4x, multiply negative by negative, which is a plus, can multiply through here, 3/2, which gives us exactly a 6/4, but yeah, divide by 2 right through. Okay, what is this? Now, this would mean that you want to find, okay, this gives us exactly the equation we want. So, which means that y equals -3/4 x, and then this one here becomes 3/2. 3/2, and you subtracted 2. And upon subtraction is -3/4x, and this is 3 minus 4 minus 1/2. Okay, take note of that one there. Take note of that one there. Okay, good, 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 good. Okay, good. Now, there are a couple of things therefore that are very important. So you are here and you want to find the y. So, but now this gives us the equation of, it gives us the equation of FC. So this one here is the equation of FC. Okay, if this is the equation of FC, you'd have to find then something important. You'd have to find the y. So the equation of FC, right? So y equals -3/4x minus 1/2. Okay, yeah. Anyway, this is right through C with the coordinates 6 and y, giving us x and y. So y equals exactly -3/4. The x is 6 minus 1/2. So you divide right through by 2, which is -3. 2 goes up in times there. Okay, so 2 goes up in times into 6. It goes 3 times and 2 times there. Minus exactly 1/2. So y equals -9 minus 1/2, and y equals -10/2. -10/2 is -5. Okay, yard. So therefore, we have that y is a -5. Just pay attention to that and make sure you understand that part. So obviously at this point, we're able to see that y equals -5. Y equals -5. And okay, there are many ways to do this, and we can certainly be able to use a couple of methods to get the answer to this. We can even do it in the least amount of steps. For instance, a student can come here and say, okay, Yar, you want to find you're dealing with the gradient of the fact that FC and FG. So you can come and say at the top here, the gradient of FC is equal to -3/4. Okay, because the reason for this would be that we already know the gradient of FG is 4/3, but the gradient of FC itself is minus 4/3. FG is 4/3. So FG is 4/3. A perpendicular line segment would have um, the negative reciprocal of the gradient. Why the negative reciprocal? The negative reciprocal because we have FC is perpendicular to FG. Okay, we good. Now, the minus 4/3 gradient is the gradient of the line FC, so which means that we can come here and then say we want to find here the gradient, so we can come and say this one minus this one. So we can call this one x1, y1, yeah, and then you can call this one x2, y2. So you can come here and proceed in the green color and say y2 is y and y1 is going to be minus, which is going to be plus 2. You divide by the x2, which is 6, minus x1, which is 2. And therefore, this is the gradient of FC, and the gradient of FC is minus 3 to 4. Minus 3 to 4. You see, in the end, then, what we're then getting here is the following. Okay, it is the following. It is the fact that this is the case. If you solve here for y, it is very obvious that y equals minus 5. You see, we've already solved it here. But yeah, manipulating this shows that y it's actually a minus 5. How do we know that? Okay, I can show a little bit more steps here to just satisfy, to quench the thirst of the curious. Okay, okay, because 6 minus 2 is a 4. And if you cross multiply, it's going to be 4 here over 4 out of 4. So you have 4 here and 4 here in the denominator, which means the tops are equal. Y plus 2 equals minus 3. And this means that y is a minus 5. Pay attention to this. This gives us exactly y equals minus 5, which is what we want. Okay, it's exactly what we got in the previous question. Y equals minus 5 is the y component of the point C. Pay attention and follow the trend of thought. We proceed to the next question. Right, we need to find the size of the angle theta. How do we find the size of theta? We use one formula, but it's only one formula that can help us find the size of the angle theta. But first things first, we can easily quickly find the angle beta because you already know the gradient of the line FG. Okay, what did we find the gradient of the line FG to be? We said the gradient of the line FG is 4/3. Okay, so we want to find the angle of inclination. So now the gradient of the line FG is actually equal to 4/3. Okay, now if this is the line, the gradient of line FG, which is actually equal to 4/3, now, the couple of things that are very important, we use the fact that the angle beta remains the angle of inclination of the line. So now we know we use the formula, the gradient of FG is, which is FG here is the tangent of beta. Okay, the tangent of beta is 4/3. Okay, want to find beta. Beta is octane, 4/3. Okay, what is octane 4/3? This beta. Octane 4/3. Using calculator, using calculator. Okay, we use the formula gradient is the tangent of theta. Students learn this one. So if they ask you to find the angle of inclination in analytical geometry, you use m equals tan theta. That is the formula. Get marks for that. Okay, but now we already know the gradient of the line FG is 4/3. Okay, but now the angle of inclination here is FG because here is F and here is G, and the angle of inclination is beta. Pay attention. Right, if this is beta, here is the angle of inclination. So what we then do here is therefore that this is octane 4/3, and octane 4/3 is 53,13 degrees. Okay, it's 53,13 degrees, which means now we're back to grade 10. Grade 10. Okay, grade 10 teaches us something. If this is the angle A and this is B and this is 1, 2, the angle C, okay, grade 10 teaches us that the angle C2 is the exterior angle of the triangle. So the angle C2 equals the angle A plus angle B. Pay attention to this because we then say exterior angle of triangle. Okay, once you write this in the exams, the examiner knows, aha, the exterior angle of the triangle is the sum of the interior opposite angles. We pay attention and we move forward. So we have this exterior angle here. So now we have this little triangle that sits like this. So we have this angle here is equal to this plus that. Okay, we've already got beta. So we're going to say the angle 104, the angle 104, 04 degrees. The angle 104, 04 degrees in exterior angle of a triangle is beta plus theta. This is exterior angle of triangle. So now, which is 104, 04 degrees equals the angle beta, which is 53,13 degrees plus theta. Okay, right. This one is equal to this plus this because we are dealing with the exterior angle of triangle. So, but the angle beta we already have got here in the same question, which is 53,13 degrees. And therefore, we have that one, which is 104,04 degrees minus 53,13 degrees. And what is this? What is 104,04 degrees? What is the answer? 104, that, which is exactly 50,91 degrees. Okay, so the angle theta, which is what the examiner wants, the angle theta here, ideally it is approximately 50,91 degrees, and that is what we want. And we continue to solve more problems. We continue to solve even more problems. And let us continue to solve the problems and enjoy ourselves. Let us indulge in more mathematics. We solve the next question. Right, so we're good. Right, we need to find the length of AC. The minute the examiner mentions length, they want distance. They want distance between 2 points. What is the distance between 2 points? Now, we want to find the length of NC. The length of NC. Right. Okay, Mr. Examiner, this is very, very interesting to ask. But looking at this, we don't know the coordinates of N yet. And they want the length of NC. The examiner is being tricky a little bit, but they are here to, they're out to get you. But you already know the coordinates here are 6 and -5. We got y to be -5, so we sorted there on that front. But we are very fascinated by the fact that we want to find, so this is a right angle to triangle, and therefore we have the hypotenuse. We have an adjacent, we have an opposite side, opposite the angle theta, for example. We have a side adjacent to theta, so we good. Right. But something very important. To find the length of NC, we just need the length of one side, but only one, meaning we have FC. FC, which is exactly x2 minus x1 squared plus y2 minus y1 squared, and we find the square root. So we have FC. Okay. Now, if we want to find FC, this is exactly x1, y1, and this is x2, y2. And what is x2? Is 6 minus x1, which is that squared. What is y2? Is -5. Y1 is -2 squared. And okay, yeah, let us write clearly here. This one is a square, and the square root is extended. All right, so you have that, and you square that. So you have this. Okay, so in the end, then you have 6 minus 4. 6 minus 2 is 4. You square that to get a 16, and we have -5. Um, Here you have -5 plus 2. You can write like that. We have 60, and you square these is the 9. We have 25. The square root of 25 is the 5 units. 5 units. Okay, yeah, FC FC is 5. Okay, FC is 5. If FC is 5, then we can go back to grade 10 and say, Mr. Examiner, we know what to do because this one is the angle theta. This one is the angle theta that sits at the top. Right, so we know that therefore this one is the angle theta that sits at the top. And if this is the angle theta that sits at the top, this one is 5. And okay, if this one is 5, we know very well that this is the opposite side. And therefore, we know the angle theta already. What do we know the angle theta to be? We have already got it from the previous question. The angle theta is 50,91 degrees. So good. So the angle theta is approximately 50,91 degrees. So now this one we know it's and now okay, if this one is the N and this one is the right angle and this is F and that is C, we can easily find NC, which is opposite hypotenuse, meaning the sine of 50,91 degrees, it is the opposite over the hypotenuse, which is NC, which means NC is 5 divided by the sine of 50,91 degrees. So which means that NC is 50, it's 5 divided by that, and it is exactly 6,44 units. It is 6,44 units, and that is what is required. Right, so it is 6,44 units, and that is the length of NC. So here's the length of NC is actually that one. But look at how we found it because, okay, to find the length of NC, another student can say, okay, why don't we just use the length formula to find the length of NC? Obviously, we can use the distance formula to find the length of NC, but there are a couple of things that are very important because the n coordinates are not known. Since the n coordinates oh, are not known, okay, we have exactly that. We have exactly that. Okay, yeah, we move to the next question. We proceed to the next question as we solve more mathematics problems. Move forward. Okay, the next question says question 5. Okay, we were looking previously at question 4. And okay, for the first time, we have a taste of trigonometry. Trigonometry appeared in the June for those who wrote paper 2, but for those who are yet to write paper 2, we have a chance to have a very great feeling of this particular paper here. Right. So, the couple of things that remain very, very important here. Right. In the diagram below, you have T with the coordinates X and 15, and T is a point in the Cartesian plane such that OT is 17 units. So we have that OT is 17 units. Right, so if OT is 17 units, we have P with the coordinates -2 and A. So P with the coordinates -2 and A lies on OT, and this lies on OT. K is a point on the positive x-axis. Here is K as a point on the positive x-axis, and TOK is it's the angle theta. Determine the aid of the diagram, the following the value of x. We want to find the value of x. Right, so how do we then find the value of x? Right, so to find the value of x, obviously you can see that x is the x coordinate of the point T, and we find the x coordinate. We want to find the x coordinate of the point T. How do we then find the x coordinate of the point T here? Right, to find the x coordinate of the point T, we can use Pythagoras theorem because we already know OT. So we already know that OT is actually 17 units, okay? Meaning that at this point, what we need to have here is Pythagoras theorem, x squared plus y squared, right? So we're going to have exactly that. So we have x squared plus y squared is r squared. Right, so this is Pythagoras. This is Pythagoras. Okay, if this is Pythagoras, then we have the following. So your, this is x and y. So which means that this is exactly x squared plus 15 squared, and the square of the radius is 17 squared. So which is x squared equals. So you have now 17 squared minus 15 squared, and this gives us 64. And this means you have x squared here, and you have the square root of 64. You put plus or minus, and this should mean x is plus or minus 8. X is plus or minus 8 there. Okay, so obviously at this point, we know that x is negative. So calculate the value of x. So x is going to be actually minus 8. So obviously this would therefore imply that x is only minus 8. Why? Because x is on the negative side here. So you'd have that x is minus 8, whereas y is 15. X is minus 8, whereas y is 15. Okay, so we have exactly that. We move to the next question. Move to the next question and solve the next one. The next one. So that is the value of x, and x is minus 8. X is minus 8. Okay, all right. We move to the next question right now. In the next question, I want to find the size of the, or rather the tangent of theta. The tangent of theta. So now if this is the diagram we have, right, this is the diagram we have, and we want to find the tangent of theta. Right, to find the tangent of theta, we remember SOHCAHTOA. We remember SOHCAHTOA. And if we remember SOHCAHTOA dealing with the tangent, which is opposite of adjacent, so obviously we already know that x is minus 8 here, right, and then we already know that y is 15. Right, so we already know that y is 15. So that we want to find the tangent of theta. So tangent of theta is opposite of hypotenuse, rather opposite of adjacent. So opposite of adjacent is actually exactly the 15 out of minus 8. 15 out of minus 8. So the tangent of theta becomes actually 15 out of minus 8. And that is what we want. And that is what we have got. Okay, so because the examiner said determine without the aid of the diagram, or with the aid of the diagram, the following. So yeah, with the aid of the diagram, the following. So yeah, we determine the tangent of theta. So the tangent of theta is minus 15 of 8, and we have exactly the answer that we've got. We have exactly the answer that we've got. We move to the next question. Determine with the aid of the diagram the following. The cosine of 180 degrees minus theta. So at this point, if you have the cosine of 180 degrees minus theta, in which quadrant is 180 degrees minus theta? Okay, sorry, you'd have to just recall the cast diagram. And in view of the cast diagram, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Right, so if we go back here, we have 180 degrees minus theta. We have 180 degrees plus theta. We have 270 degrees plus theta. We have 270 degrees minus theta. We have 360 degrees minus theta. We have 360 degrees plus theta. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So now if you say 80 degrees minus theta, you are in quadrant 2, in which only the sine is positive, meaning the cosine is going to be negative cosine theta. And therefore, what is the cosine here? So in view of SOHCAHTOA, we have that the cosine of theta becomes exactly the adjacent of hypotenuse. Okay, so dealing with this here, Right, so we know that our x is minus 8, but we know that our y is actually 15 from here. So now, if we look at the cosine is adjacent of hypotenuse. The cosine of theta is actually adjacent of hypotenuse, and we already know that OT is 17 units. So if you're dealing with this, and then we then say that adjacent over the hypotenuse, so it is actually exactly the adjacent side, and the adjacent side is what? Is actually this one here, which is minus 8. The hypotenuse is 17, and this is 8 out of 17, and we're done. Okay, so we to get this, so I mean, as a consequence, able to see that this cosine here is 8 out of 17 as the examiner wanted it. So pay particular attention and make sure you understand. These are very, very important things for us to take into account, and we are learning these things and making sure that we get the most out of this as a consequence. So let us move on to the next question. We move on to the next question. Okay, y'all. Yes. So, y'all, next question. Okay, now to determine with the aid of the diagram, the following, you need to determine sine squared, the sine squared of theta. So determine the sine squared of theta. So that's what the examiner wants. So you'd have to determine the sine of theta squared. Okay, what is the sine of theta? Here, this is the angle theta, and therefore to find the sine of theta, you already know that our x is minus 8 and our y is a 15. So the sine, okay, this one is 17. So that the sine is opposite of hypotenuse. Okay, so in view of SOHCAHTOA, the sine becomes opposite of hypotenuse. The sine is opposite of hypotenuse. Yeah, opposite of hypotenuse, which is actually the same as 15 out of 17. You square this. If you square 15, you have 225. And you square 17, you have 289. You have 289. And that is the answer. That becomes the answer. That becomes the answer. Any question? Any question? Any question? In the absence of a question, we'll proceed to the next point. To the next point. Now, in 5.1.5, you have the tangent of the angle theta. Okay, we want to find here the value of A. Right, we want to find the value of A. And therefore, to find the value of A is sitting here. And the question is, how can we be able to find the value of A if you already know some information? You already have some information about the tangent of theta. We know some particular trigonometric equations. So to find the value of A, and here is the A. How do we find the A? It's sitting there. How do we find a point that is in the middle like this? So we use the trig ratios that we know, but most importantly, we know that our x is minus 8, our y becomes 15, and therefore we would then say the tangent of theta. The tangent of theta. The tangent of theta. Right. So the tangent of theta at this point becomes what? We know that the tangent of theta, we use SOHCAHTOA. Right. We use SOHCAHTOA. Using SOHCAHTOA, we know very well that the tangent is opposite of adjacent. This is the angle opposite of adjacent. So opposite of adjacent is 15 out of minus 8. But this is the same as what? We can be able to draw a small triangle like this. And if we draw a small triangle like that, just dropping a line below point P. And therefore, we have the fact that this is our x. Our x is minus 2. Right, so we have that our x is minus 2. And if our x is minus 2, you have that our y equals a. Our y equals a. Right, so now at this point, um, what then do we have? So it means the tangent of theta can be found in two ways. We can find tangent of theta looking at the big triangle, the biggest one, where we then deal with the opposite of the adjacent. Dealing with the small one, here we have the opposite of the adjacent, sorry. And the opposite is exactly the A. The adjacent is -2. So the tan of theta is two different entities, and we are in business. We cross multiply this, we get 15 divided by -8, and we have -2, which is 8, and 2 goes, times here, you have 15 divided by 4, and that is the numerical value of A. Right, so we have got that because 2 goes times into -8. -2 goes times into -8. It goes 4 times, giving us 15 out of 4. Now, we then have that the numerical value of A is 15 quarters. So pay attention and make sure that you understand this and make sure that all is well and we're good. And we proceed to the next point. Right, proceeding to the next point, we try and attempt the next question because we're good and we can be in a position to try more questions and learn more mathematics. Let's look at the next question. Okay, the next question is about proving identities. Let us prove some identities and indulge and enjoy ourselves. Right, question 5 is about proving identities, but we look at the first question first in 5.2. Want to simplify without using a calculator the first identity for 70 or this particular expression. Want to simplify without using calculator, and the answer is 7. Let's see. So now this pointer would find the sine of 180 degrees. So 120 is 180 degrees minus 60 degrees. And therefore here we have 210 degrees, which is a 180 degrees plus 30 degrees. This is the tangent of 360 degrees minus 45 degrees. Okay, yeah, this one, the 27 degrees is called an acute angle. And this acute angle, we can make it to be the same as this one here. So we really can indulge and enjoy ourselves. And in enjoying ourselves, we have most certainly the following there. So we can decide to make this the same as that. So we can use cosine 27 is 90 degrees minus 63 degrees. Right, because 90 minus 63 is the same as 27. Okay, we're good. So we perform further division here like this, and we come to the denominator, and we have the sine of 63 degrees, and we have the following. Okay, now the 540 is 360 degrees plus 180 degrees. So you add 360, you add 100 to 360, get 400, and this is 540. 180 minus 60 is the same as an angle in the second quadrant, so that the sign is positive in view of the cast diagram for this. Okay, the cast diagram. So you have 0 degrees, you have 90 degrees, you have 180 degrees, you have 270 degrees, you have 360 degrees. Right, so this is 180 degrees minus theta, 180 degrees plus theta, 270 degrees plus theta. You have 270 degrees minus theta. You have 360 degrees minus theta. You have 360 degrees plus theta. You have 90 degrees here. 90 degrees minus theta, you have 90 degrees plus theta. So if you have 180 minus 60 degrees, 180 minus 60 degrees in angle in the second quadrant in which the sign is positive. So this is positive, the sign of 60 degrees, 180 degrees plus 30, 180 plus is an angle in the third quadrant in which the sign, in which the cosine is negative, and this gives us negative cosine of 30 degrees there, and 360 minus 45, 360 minus 45 is certainly an angle in the fourth quadrant in which the tangent is negative, because only the cosine is positive, and this gives us the negative tangent of 45 degrees there. Next point, we have 90 degrees minus 63. 90 degrees minus 63 is an angle in the first quadrant in which all trigonometric ratios are positive. So we're going to have a positive there. But obviously, there's a cofunction change in view of what we call the Coco rule. Right, in view of what we call the Coco rule, and the Coco rule is a very, very important rule that we need to mention. So, right, so if you look at the Coco rule is very clear about a couple of things. It's the fact that if you have cosine, cosine theta can be changed to sine theta. Right. So in other words, cosine, if you scrap the co, it becomes sine. And if you put a co on the sine, sine becomes cosine. So you can move in either direction. Okay. Right. So if you have 90 degrees minus 63 degrees, that is 90 degrees minus, which is in the first quadrant where all trig ratios remain positive. But we know that this cosine will change to the sine function, making the sine function, obviously everything is positive there, and we have the positive sine of 63 degrees. Okay, bingo, we've got it, because this is Eureka. It's a very Eureka moment, because we have the sine of 63 degrees in the denominator as well. We have the sine 63 in the numerator, and these two guys will most certainly cancel each other. Pay attention to this. 540 degrees is the same as 360 degrees plus 180 degrees, but 360 plus theta is an angle in the first quadrant where all trig ratios remain positive, so that this becomes a positive cosine of 180 degrees, like so. And we proceed to simplify. But in our attempt to simplify, there are some of these things that simplify with so much ease and simplicity, like the sine of 63 degrees that cancels out. And we have our special triangles, and these are beautiful, but now we love them because they are awesome. But remember, the examiner was clear without using a computer or a calculator. So now we need to remember the kind of triangles we need, right? If this angle here is a 30-degree angle, this one is a 60-degree angle, it's 2 is square root of 3 is 1. And therefore, you have the sine. Okay, we use SOHCAHTOA. We use SOHCAHTOA. So right now you have the sine, which is opposite of hypotenuse in dealing with the 60 degrees, which is opposite of hypotenuse, which is actually the square root of 3 out of 2, opposite of hypotenuse. And therefore, you have the following. Now, the cosine 30 degrees in view of this SOHCAHTOA, cosine is adjacent of hypotenuse dealing with the 30 degrees, and therefore if you have adjacent of hypotenuse at 30 degrees, adjacent of hypotenuse, which becomes also the square root of 3 out of 2, so this is minus the square root of 3 out of 2, like so. Now, this to get another triangle, and obviously in view of our special triangles, this triangle here is a very, very important one that we need to learn, called the special triangle for the 45-degree angles. And we have the following right here. This is 45 degrees, and this is 45 degrees. This is square root of 2, and these are 1, 1. Okay, so if this is 1, 1, and we have this 1, 1, and that. So the tangent of 45 degrees is opposite of adjacent in view of the 45-degree angle. If this is 45 degrees, opposite of adjacent, opposite 45 is 1, adjacent is 1. So this is going to be exactly minus 1 over 1, okay? Then we divide everything by the cosine of 180 degrees. The 180 degrees is an angle at pole, and therefore this one is actually exactly a minus 1. Upon careful simplification, the negative gives us a plus, and therefore, if you divide the plus by negative, everything is going to be minus, and therefore, you have the square root of 3 by square root of 3, and this gives us 3 out of 2 by 2, it's a 4, and this gives us minus 3 out of 4, and therefore, this is the answer to the question. So we have solved these, but we have solved these in detail, and we migrate and move forward to the next question. And moving to the next question, we have the following aspects that remain very, very important for us. We tried right now to solve the next question, but in solving the next question, we're going to solve the next question in a step-by-step fashion as follows. Right, so now we need to prove this identity. To prove this identity, it's something very, very easy. To prove identities in mathematics, we take one side of the equation and demonstrate that it is actually equal to, or the side can be reduced to the other side. So what we do is we let the left-hand side, we're going to take the most complicated side. So we take the left-hand side, which is 1 over cosine theta. We have cosine theta here divided by 1 plus the sine of theta, and this is the same as what? So then what we have here is the following. So we're going to take cosine theta with 1 plus the sine of theta. We divide this by this. We divide this by cosine theta, getting 1 plus sine theta by 1, which is 1 plus sine theta, and we have minus here. We have this divided by 1 plus sine theta, which is cosine theta by cosine theta, which is actually cosine squared theta, like so. And what is the meaning of this here? So this is 1 plus sine theta minus the cosine theta. Cosine squared is 1 minus sine squared theta. You divide everything by cosine theta into 1 plus sine theta. And therefore is 1 plus sine theta minus 1 plus sine squared theta divided by cosine theta into 1 plus sine theta. So obviously 1 minus 1 becomes 0, and we have sine theta plus the sine squared of theta, and you divide everything by cosine theta into 1 plus sine theta, like so. And we proceed to solve this. But now pay attention to what we've just got. In the numerator, we can take out sine theta as a common factor, leaving us with 1 plus sine theta, and you divide everything by the cosine theta into 1 plus sine theta, like so. Okay, we proceed. Okay, now look, the sine cancels out, leaving us with the sine theta over cosine theta. Pay particular attention. So we've achieved that the left-hand side is the same as the sine theta over cosine theta. And this means that the left-hand side is our friend, which is sine over cosine, which is the tangent of theta. The tangent of theta is actually the right-hand side. So we've got the right-hand side of this particular equation. So you're welcome to ask us questions. In the absence of questions, we proceed to the next point. In proceeding to the next point, we solve more problems in a step-by-step fashion, and we get more results. Let us get more results right now and be excited and get what we need. So we good with 5.3, and then we move to the next point. We get 5.4. In 5.4, you need to determine the general solution of that particular equation. Let us learn the concept of a general solution. Many times in the exams, they'll ask you to find the general solution. We're asking the question, how do we find general solutions? So if you've been given 3 sine x, which equals to the tangent of x, and how do we therefore deal with this? Okay, we have 3 the sine of x, which equals 2. The tan is sine x over cosine x, and we cross multiply these things here. If you cross multiply these things, which is 3 sine x cosine x, which is 2 sine x, and therefore we have the following. You have 3 sine x cosine x minus 2 sine x equals 0. Okay. Sine x, which is the same as 3 cosine x minus 2 equals 0. Okay, we have this. So which means that we have sine x equals 0, or you have the following, right? Or you have 3 cosine x equals 2. Upon division by 3, you have cosine x equals 2 out of 3, and sine x equals 0. So we're going to obviously do this step by step, but first things first, we're going to just deal with the sign of x. So if you have that sine x equals 0, dealing with that case first, so the sign of x equals 0 at the poles. It is equal because now if you have this one is 90 degrees, 0 degrees, 180 degrees, 207 degrees, 360 degrees. Okay, yeah, we're good. And then this one here, we can just remove like this. Okay, and this gives us exactly 90 degrees, meaning the sign is 0 here, which means that x equals 180 degrees. Okay, 180 degrees, and then you can add to that the multiples of the thing. So let's first get what we need here. Right, let's first get what we need. The best would be that obviously you first get a reference angle, and if you get the reference angle, because if you have the sine of x equals 0, and then you have the reference angle, right? So the reference angle will be arc sine. So yeah, the sine of x equals just 0 as a ratio. And you then have that the arc sine 0 equals exactly 0. Okay, because the sine of 0 itself is 0. Right, so this would be like 0 degrees. Okay, right. Now, if this is equal to 0 degrees, the couple of things. So x, therefore, is 0 degrees plus 360 degrees by k, where k is an element of the set of integers, or x equals, okay, so that is the 0 degrees you've got, but you add multiples of 360. Why? Because the period of the sine function in view of the sine graph, we're to discuss graphs, and in view of the sine graph, you'd have that therefore the angle is 0 degrees there. Okay, yeah, but the period of the sine is 360. That's why it's 360 by k, where k is an element of integers. But now also, we know that the sine is also 0 at 180 degrees, and this gives us 180 degrees plus 360 degrees by k, where k is an element of z. Where k is an element of z, okay? So we have that. So that in the end, then you have a separation. We have another equation to deal with. So if you have, for instance, you need to find the cosine x, which is 2/3. Okay. Now, this 2/3 means you have the cast diagram. So if you have that the cosine is positive, it is positive in the first and positive in this quadrant, but first let's get the reference angle. The reference angle is going to rise from arc cosine 2/3. And arc cosine 2/3 gives us 48,19 degrees, which means that x equals, okay, in the first quadrant, it means that x equals 48,19 degrees plus 360 degrees by k in z. Okay, and x equals, okay, that is 48, that, and then you add this one, which is 360 degrees minus 48,19 degrees plus 360 degrees by k in z. Okay, x minus 48,19 is going to give us 311,81 degrees plus 360 degrees by k in z. Okay, so this becomes the result. So now, okay, we have to find the general solution to this. And that becomes most certainly the general solution to this. Okay, but it's something that we can actually note the here. Okay, let me just make mention of the fact that you have a couple of results. So we have got this solution here, which is the 0 degree solution associated with the reference angle, but also you have this solution here. And then you have this solution in the first quadrant. And then you have this solution here in the fourth quadrant. Now, we have another thing, which is x equals. Okay, because we got that this, okay, the cosine function is called an even function. Right. Being an even function has implications for it. And it therefore means that once you get a reference angle as this, you can then say it's plus or minus 48,19 degrees plus 360 degrees by k, where k is an element of z. Okay, so this here becomes the desired result, but yeah, it becomes what we most certainly need. So pay particular attention to these kinds of things that matter. But also the negative angles in mathematics, the angle of the size 48,19 is an angle measured in a positive sense, which means it is measured in a counterclockwise direction. The angle for the negative 48,19 degrees is an angle that is measured in a clockwise direction, which is measured in a negative sense. And in mathematics, the negative sense is the clockwise direction, meaning it yields negative angles in the Cartesian plane or in our Argand diagram. Right. Our Argand diagram is a diagram on which we are able to measure angles. So now it is our standard Cartesian plane. We proceed to the next question. But now we have the following aspects that remain very, very key and extremely, extremely important. Okay, I want to make mention of the fact that obviously in the first case when we did not use the plus or minus, we got that x was 48,19 degrees plus 360 degrees by k, where k is an element of integers. We also got an angle in the fourth quadrant, which was 311, 81 degrees, etc. But now, look, this gives us the 311, which is an angle in the fourth quadrant. And therefore, now you have this one here, which is the minus 48,19, an angle in the fourth quadrant. We proceed. Okay, I want us to discuss graphs a little bit. Some of you might have not seen graphs, but we have a very, very splendid moment this evening when your minds are cool and you are free from the bustling sounds of the day. And we want to understand graphs and functions. How do we understand graphs and functions in trigonometry? Your teachers have not yet spent time on graphs, but believe me, these June holidays, we're going to have time, at least 3 times a week. We're going to increase our frequency of discussions to at least 3 lessons a week. Mathematics, 3 lessons a week. Science, something new will happen. You will be born again. There's going to be a transformation. So question 6 is on graphs and functions. We're fascinated by graphs and functions and want to learn the graphs. And these graphs have not quite been popping in the junior exams, but believe me, you need to understand them. We need to spend ample time on graphs and functions. Question 6 is no exception. Now, the graphs of the functions f of x equals a cosine b theta and g of x equals c, the tangent of theta, for x between minus 180 degrees and 180 degrees. From minus 180 degrees to 180 degrees are sketched below. The graphs intersect at the points P and Q. Now, the point P has the coordinates 58 degrees and 1,6, which is this point over here. The point Q is another point, which is the point of intersection. So obviously the graphs intersect at the points P and Q. The examiner is very clear about it, but also the examiner has clearly labeled the points and has shown the points on the diagram. Okay, now remember, our lesson tomorrow is on science. So we're going to be starting at 4 p.m. So get yourself ready. For those students who would wish to have classes earlier on Sundays, we have atheists who do not maybe go to church on Sundays. We can start your classes earlier if you're free. I mean, as early as 6 a.m. or 4 a.m., 6 a.m., 8 a.m., 10 a.m., etc., etc. Okay, write down the range of f. Okay, now you want to write down the range of f. This is f. Now, the range is a set of the y values. So now, if these are the y values, you need to take into account. So you have the y here, and you have this one here and this one here. So the range therefore would be, we start from the smallest one. The smallest is the -3. You end up with the biggest one. The biggest one is 3. And this tells us therefore that this graph here, the graph of f, the cosine function f, it has its minimum value at -3, and its largest value sits at 3, and this is the function we want. So it starts from -3 and it ends at 3. So that becomes the question. So pay particular attention to this and make sure that we have what we want. We have what we want. Okay, if you do not write your answer like this, you can write your answer differently. You can say that y is an element of the interval, and then you put -3 up to 3, like so. And this is exactly what we desire, and this is giving us the values of y for which the graph itself is defined. Right, so we proceed. In 6.2, if M has the coordinates -5 degrees and -1 lies on G, determine the value of C. Right, so determine the value of C. Now let us look at that one. Sorry, C itself is this guy, is this symbol that's sitting here. This is the coefficient of the function tangent of theta. Sorry, now we are interested in actually finding C. So to find C, you need to look at the tangent of theta, the graph G. So here's the graph G, and also here's the graph G. It actually, obviously, you can see it moves this way, but also it progresses this way over here. Now, there are a couple of things that remain extremely important for us to consider. What are the things that remain very important for us to consider? We want to determine the value of C. How do we find the value of C? To find the value of C, we move forward as follows. Now, we need to take a point on the graph. Just take one point on the graph and to be able to use that one. So we can use any of the points on the graph there. For example, somebody can take the point P, for example. Okay, it's a point whose coordinate we know. Any other point there you can as well take. Now, let us take the point P. So in other words, we write G of x. And G of x is C, the tangent of theta. But now this function G it passes through P with the coordinates 58 degrees and 1, 6. This gives us x and y, which means y is 1, 6, which equals c, the tangent of 58 degrees, which means therefore at this point we would be interested in getting c dividing by the tangent. You'll be able to see that c is 1, 6 divided by the tangent of 58 degrees. Okay, so now let us use our computer. Right, so we're gonna do the following, and we're gonna actually use our show taskbar, and I have put the calculator somewhere. Let me see if I still have the calculator over there to use, or maybe it went. I think that the calculator went there. Okay, now the couple of things that obviously would remain very, very important for us to take into account. You'd have to look at the fact that um, you need to divide the two. So to divide the two, you'd have to use, can use any of these things here. Right, you can use any of these things and see what if we can obviously launch here. Let me see. If you say Casio, let me see what this is gonna bring. For instance, right, I have a couple of calculators I can launch. Maybe let me look at this one. Right, so if you have this calculator here, you can launch it and then you can divide. Okay, you can divide a couple of things. And you can then say 1.6. So you can launch this one and you can then say 1.6. You divide it by 1058. And then you get the answer. All right, so the answer is 0.9999, etc. And this would give us exactly a 1. So at this point, this would mean, therefore, that if you divide the 1.6 by the tangent of 58, you get that C is 1. So that is what you need to write down. So C is 1. So sees one there. Okay, look at how we have determined that as well. Okay, but also you are told that the M is given, so which would give a more accurate result. Because if the M is minus 45 and minus 1, you would use the fact that the G is C, the tangent of theta, which means that the M with the coordinates minus 45 degrees together with a minus 1, you'd have X and Y, so that the Y is minus 1C there. Okay, minus 1, let's write clearly over here. So the Y itself is equal to minus 1 C, and you have the tangent of minus 45 degrees, minus 45 degrees. So that we have minus 1 equals C. The tangent of minus 45 is a minus 1, so that C is 1. Right, so you could see therefore that they clearly were able to get that C is 1 there using the point M that is given, but also using the point C. You can see it, that we got the same result over there. We move to the next question. Right, you need to write down the values of A and B. Right, let's write down the values of A and B. Now, A and B themselves are parts of the components of the function f. The function f, it's our cosine function. It's a cosine function. It's a very interesting one. Let's take a look at this function and spend some time to understand it. But first things first, there's something called the amplitude of the function, which is the coefficient, meaning therefore that we're able to see that now using the function f of x, equals a cosine bx, it would mean therefore that a equals 3, and therefore that would mean that f of x equals 3 cosine bx. Okay, so if it is 3 cosine bx, we need then can be in a position to find the b. Okay, to find b, you need to use any other point. And to use any other point, for instance, because it is part of this, you can look at the fact that take any point, just any point on the function. For example, you can take exactly, let me see what point you can take. Okay, you can take this one because you're dealing with the point F. Can take this one, for instance, but some of these now, X is 90 degrees here and Y is 0. So you can take this as well. Any point, you can take this one here. Okay, when Y is 3 and X is 0, not so good. So here, you can take this one, for example, and you can take a couple of other points. Like you can take the 1,6 point, but yeah, let us try a point with whole number components. Let's try this one when we have this. Okay, right. We're gonna say it is this function f passes through x is 90 degrees and y is 0. Okay, x is 90 degrees and y is 0. So if y is 0 equals 3 cosine, all right, and then we have that the x is 90 degrees. So you'd have like 90 degrees B. Divide by 3, getting 0 equals cosine of 90 degrees B. Upon careful examination, we get arc cosine of 0. Arc cosine of 0 is 90 degrees B. What is arc cosine of 0? Arc cosine of 0 is going to give exactly 90 degrees, which is 90 degrees B. And dividing by both left and right by 90 degrees, this gives us B equals 1. B equals 1, which means that A equals, we've already seen that A equals 3 because it is the amplitude of the function, with B equals 1. So that is the answer. That is the answer. And that becomes the answer. Next point. So yeah, write down the values of A and B. A is 3 and B is 1. Determine the coordinates of Q. The coordinates of Q. The coordinates of Q, and Q sits here. Want to find the coordinates of Q. And what are the coordinates of Q? Well, Q is a very interesting point. Q itself is nothing other than the point of intersection of the two functions. And how do we therefore find the point of intersection of the two functions? So we proceed as follows. Now, it is very, very clear that in view of the points, there is a reflection. So there is some distance here, because if this is given and is drawn, okay, now you can see some distance between the two. So there's this one here, and there's this one there, and there's this one here, and there's this one there. Okay, now in particular, we're interested in this here. We're interested in this part. We're interested in this part. So now, what are the coordinates of Q? Okay, so now we are able to see that this is like X and Y. So the Y is the height, taking to 1.6. So because of the nature of the graph here, the tan is like this and the tan bends down, it is most certainly expected that this side itself is going to be minus 1.6. And that means the y component is minus 1.6 of the point Q, and the x component. What is the x component? Okay, if the distance here between 90 degrees and 58, so you would say, okay, it's exactly 58 degrees here, but 90 degrees minus 58 degrees would give us 90 minus 50 would give you 40, and 40 minus 8 would give you 32. Right, we give you 32 degrees. Okay, that means you have that this distance here is 32 degrees that spans across. Okay, it's 32 degrees that spans across here. Right, so, I mean, if it is 32 degrees, you'd have to allow another 32 degrees here, meaning this is actually 32 degrees. Right, so if you have 90 plus 32 degrees, it is exactly okay, 122. 90 plus 32 is 122 degrees. Take note of that. So this is going to be 122 degrees. So this is 122 degrees, and the minus 1.6 there. So the coordinates of Q therefore are exactly this. Okay, so pay attention to this. So what did we use? We just use what we call symmetry. We use the symmetry analysis to get the answers to this particular question. We'll move forward and we'll try the next point. Okay, K lies on F such that Km is parallel to the y-axis. Km is parallel to the y-axis. Km is parallel to the y-axis. Calculate the length of Km. calculate the length of km. Okay. Right. So to find the length of km, this becomes very important. So the question is, you have the point of intersection here. And now, if this is, if you look at this is 45 degrees, 90, plus 45 degrees is 135 degrees plus 45, which is 180. This is minus 45 degrees and minus 90 minus 135 degrees and is 0. Okay. So in minus 45 degrees means what? So if you have the K with the minus 45 degrees, the K is minus 45 degrees. Okay, so at K, for instance, you have that X is minus 45 degrees, but also at the point M, you'd have that X is minus 45 degrees. And what then do we have? What then do we have? Right. So if you have x is minus 45 degrees, then what is the y? Okay, now look at this because you need to look at the function f, and the function f itself has the equation f of x. Our a, we have seen that it is 3 cosine theta. Okay, so which means f of x is 3 cosine minus 45 degrees. Yeah, okay. The b is what? Okay, so you can be able to do that at x equal to minus 45 degrees, which is x equal to minus 45 degrees. And now, if you look at the effect that cosine of minus 45 degrees, which is exactly the square root of 12 of 2. Okay, I need to mention something here. In passing, that for instance, if you have the cosine of minus 45 degrees, the cosine is an even function. So cosine is an even function. Being an even function, this is cosine 45 degrees. Cosine 45 degrees, it is the square root of 2 out of 2. Okay. Okay. Now, for example, you also have the function g. C, we found it to be 1 here, so that it becomes the tan of theta. So g of x equals the tangent of theta. And the theta is actually the same as what? Okay, let's take a theta at which is minus 45. So that's what you're gonna plug in here. Yeah, it's minus 45. Okay, your which is minus 45. Okay, so okay, which is minus 1. Let me see. At m is minus 1, but at k, we need to get it is this one. So at k, it is 3 the square root of 2 out of 2. And then what is km? Okay, so this one here, it is 3 the square root of 2 out of 2, which is, okay, it is 3, it is 3 the square root of 2 out of 2. And then here it's minus 1. So it means that here, the distance here is like 1 unit. Okay, because we have up to -1 from 0 degrees to -1 here. So it's going to be like 1 unit. And then this one is 3 to the square root of 2 out of 2 units of distance. So if you find the total distance here, it's going to be, so from K to M is going to be 3 to the square root of 2, and then you add in 1 unit. So units was the many. And that is what you're going to have here. And now, which means therefore that Km is approximately, if you use a calculator here, it's going to be 3,12 units. And that will be the length of Km. The length of Km there is exactly that amount of distance over there. Let's move to the next question. Right, in the next question, if the system of axis is shifted 45 degrees to the left and the graphs remain fixed, write down the equation that is now represented by graph F. So obviously we're looking at a shift. And we're yet to look at this in detail, please. But if you are saying the axis is shifted 45 degrees to the left, right? So if the system of axis. You take the system of axis, which means you take the y and the x-axis, you shift them 45 degrees to the left. What then happens as a consequence? And you need to write down now the graph represented by a graph F, the equation that is now represented by graph F. Okay, now let's look at the fact that F is 3 cosine theta. Okay, if you have that now, you need to write down the equation now represented by graph F. If the system of axis is shifted 45 degrees to the left, what does it mean? If this is shifted 45 degrees to the left, it means therefore that the graphs themselves would be perceived to have moved to the right by 45 degrees. And this means that now the graph represented by F will be as follows. Right, so the new graph represented by F will therefore be y equals 3 cosine of theta minus 45 degrees. So if these x and y axes they move to the left, it means the graph will sort of be perceived to be on the right, and therefore to have moved to the right. And therefore, moving to the right of a graph, it means that you have a theta minus 45 degrees there. Okay, so the new equation will therefore be the same as y equals 3 cosine of theta minus 45 degrees. Right. Now, the next questions will be on other sections. And obviously, we have elapsed about 2 hours. I must thank you so much for joining us and being part of our discussion. We'll continue tomorrow at 4 p.m., at 6 p.m., and also at 8 p.m. I've made a lot of time available tomorrow to discuss more mathematics and science. Because there are many students who are writing science, I'm sure, on Monday. To be very important for us to discuss chemistry, physics, etc., and technical sciences as well. Right. From us, it was awesome having a discussion with you. And until tomorrow at 4 p.m., enjoy yourself and have yourself a good evening and goodbye. Goodbye, Pehelelo. Okay, I'm going to send the recording in the next couple of minutes. I'm going to send this recording in the next couple of minutes for you to watch and make sense of this. Some of these graphs you have not seen yet, yeah, but we are yet to spend time on graphs. Okay, we have not seen some of the graphs, but yeah, we're yet to spend time.